Hi everyone, in this video we are going to assemble this slider crank mechanism, which is typically used for reciprocating engines and compressors. Unlike other CAD software, Fusion 360 gives us the ability to build the assembly in a single file without having to import the parts into another file. We will demonstrate this ability later on. This assembly is composed of 5 main components: the pin support, the crank, the intermediate link, the slider, which in this case is a piston, and finally, the cylinder. We will create these components one by one, starting with the pin support. Like any other projects, let us begin this one by creating a sketch, this time on the front plane. So click this icon on the upper left corner of the screen, and then select this plane. Change the view by clicking the surface on the box at the upper right corner of the screen. Let us create 2 concentric circles with diameters of 0.75 inch and 2 inches. So let's click on the center diameter circle icon over here, select the origin as the center, and then type 0.75 inch. Let's do the same thing to create the other circle, only this time the diameter is 2 inches. Afterwards, let's create 2 vertical lines tangent to the circle with a length of 1.5 inches. Click on the line tool, choose this first endpoint and hover down, and make sure it's vertical and this icon appears. And then type 1.5 inches. Press enter and do the same to the other side. Now let's close this figure by connecting these 2 endpoints using a horizontal line. So once again, I'm gonna click here on the line tool and select this endpoint, hover on the other side, and finally close this figure. In order to remove the unnecessary sketches, press T and then click on the curves we want to delete. From here, we can now exit the sketch. Let's extrude this figure by clicking on this icon on the upper left corner and then select this lone sketch if Fusion 360 does not detect it yet. Set the thickness as 0.5 inches and afterwards hit OK. Although we want this object to be grounded later, we still want to apply boundary conditions on it in order to allow motion of the other components attached to it. So this will only be allowed if it is a component. So let's change this body to a component by clicking here and therefore selecting the body, right click on it, and then select Create Components from Bodies. Now you can see that it became Component 1. We can actually rename this just by double clicking on it and typing the name that we want. So in this case, I'm gonna name it Pin Support. There you go. Let's hide it in the meantime by clicking this icon, and then we proceed on creating the crank. Click Create Sketch, and then select the front plane. So here we are going to draw 2 concentric circles with diameters 0.75 inch and 2 inches just like what we did before. So I'm gonna do it first. Next, we create 0.75 inch diameter circle whose center is 3.8 inches above that of the previous circles that we had. So once again, click Center Diameter Circle, select a center that is located anywhere on the z-axis, and then input 0.75 inch. Now this is still arbitrarily positioned, so what we will do is to ensure that these 2 centers are exactly 3.8 inches apart. To do that, click on this center, press Ctrl, and then select the other center. So right click, select sketch dimension, and then input 3.8 inches. There you go. Next, create another circle concentric to this one, but this time the diameter would be 1.5 inches. So once again, click center diameter circle, click here, and input 1.5 inches. Now what we want to do next is to close this figure by connecting a point on this circle to another point of the larger circle down below. To do that, click on Line tool, point your cursor on the center of this circle, and then hover towards the left while ensuring that this horizontal dotted line over here appears. This ensures that the first endpoint on our circle is horizontally aligned to the center. Click as soon as the X icon appears. Hover down and point on any point on this circle. Trace the circle until this circular icon appears. So this means that the line that we are currently constructing is tangent on the circle. Left click, and then do the same thing on the other side. After this, press T and start trimming the unnecessary sketches. This sketch, although complete, doesn't look really nice because of these bumps over here. So this is because of the fact that this line is not really tangent to the circle. Now what we can do is to apply a constraint between these two. Click this icon, which pertains to tangent constraint because we want a line tangent to a circle. Select this circle, and then finally select the line. Now you have a nicer and less abrupt curvature. Let us do this on the other side. Now that our sketch is finished, we can finally extrude. So click extrude, and then select the sketch if it's not yet selected, and then input the thickness to be 0.5 inches in the positive Y direction. Afterwards, set the operation as new component, and then hit enter. Now we have a component without having to transform it from body. So let's rename this component as crank. You can view the pin support, and now we have a rough view of their relative position. If your work doesn't have the same positioning, no worries, we can modify that later. For now, let's sketch the intermediate link. Moving forward, let's click on Create Sketch, and then select the backmost surface that we have so far. We want the pin connection to be concentric to this circle over here, so let us create a circle with a diameter of 0.75 inch, and another one with a diameter of 1.75 inches. Again, click on Center Diameter Circle, and by the way, when creating these circles, make sure that your cursor will snap through the correct center as manifested by this circular icon. Click here, type 0.75 inch, and then draw another one with a diameter of 1.75 inches. Next, we draw another pair of concentric circles above. So this is similar to what we did in the crank before. Click on Center Diameter Circle, select the center up above, and then input 0.75 inch. After hitting enter, we can now create the other one with a diameter of 1.25 inches. So next, click on the center, press Ctrl, and then click on the other center. Let's right-click anywhere and then select Sketch Dimension. So this time, we are going to make their distance to be equal to 6 inches. So just type in 6 inches and then enter, and then you're good to go. Close this figure using the Line tool, and take note of the necessary constraint. The first endpoint must be aligned to the center of this circle, whereas the second endpoint must be tangent to the respective circle. Do the same thing on the other side. and then trim the unnecessary sketches. So remember, when trimming, just press T and click on the sketches that you want to remove. Afterwards, let's force these lines to become tangent to the uppermost circle. Afterwards, click Finish Sketch. Let's hide the crank first, and then extrude the most recent sketch that we have. So click on Extrude, select the sketch if it's not yet selected, and then type 0.5 inch. So don't forget to change the operation to New Component, and then there you go. So let's rename this component as Connecting Rod. Then afterwards, we hide this so we can construct the piston and the cylinder. Click Create Sketch, and then click on this plane over here. So we are going to draw a center diameter circle with a diameter of 7 inches. Click Finish Sketch, and then extrude it to a height of 5 inches. So let us temporarily hide this body in order to draw other entities that will comprise our piston. Click on Create Sketch, and then select the front plane. Let's create another circle with a diameter of 0.75 inch and whose center is around 0.8 inches from the origin. So kindly use the techniques that we have previously mentioned in order to do so. Afterwards, let's show the body again, and what we want to do here is to create a hole piercing through the cylinder in order for it to be attached to the connecting rod. Click Extrude, and as you can see, the sketch is already selected. If it's not yet selected, you can just click it and you can proceed. Modify the direction to 2 sides, and then set the extent of each as all. As you can see here, the operation is automatically set as cut because Fusion 360 kind of detected that you really want to cut through it. Finally, hit OK. So let's hide the body again and then create another sketch. This time, select the bottommost plane. Click on Create, hover down to Rectangle, and then select Center Rectangle. Now what we're gonna do is to create a rectangle whose width is 0.5 inch and the length is literally anything greater than the diameter of this circle. What we want to do here is to cut through the cylinder vertically upward so our connecting rod can be realistically connected to the cylinder. So of course, it needs room for it to swing through the motion at the same time, so that's why we need to cut it. Again, our width is 0.5 inch and our length, let's say around 8 inches. I'm gonna click on this sketch over here, click Extrude, and this time I'm gonna input -2 inches so the direction will be flipped on the other side. There you go. Right click on this body and then select Create Components from Bodies. Next, let's create the cylinder of the engine by sketching at the top of this component. We want 2 concentric circles, one of which has a diameter of 7 inches and the other has 7.5. So let's create them for a few seconds. There you go. Next, let us extrude this thin surface upward by around 0.25 inch. This will serve as a clearance volume of the engine or the compressor, so the piston will not bump to the cylinder. Also, we want to extrude the surface downward in order to complete the cylinder of the engine. So click the surface, hit Extrude, and then drag the arrow downward until it has a thickness of 9 inches. Press Enter, and there you have it. So far our cylinder is still open. We want to enclose the cylinder, so let's sketch a circle over here with a diameter of 7 inches. Finally, let's extrude the circle we recently sketched together with this surface over here. So click Extrude, select this circle, and also this outer surface as well. Afterwards, input 0.25 inch. Now you can see an enclosed cylinder, but unfortunately you can see what's inside. What we will do is to make this cylinder translucent so we can eventually see the motion. Click Modify, navigate down to Appearance, double-click on the folder beside Glass, double-click again on the folder beside Smooth, or if you have other preferred appearance, that would also be good. Left-click and hold on Clear Glass over here, and then drag it on the cylinder we want to change the appearance of. There you go. You can now see the piston inside. Of course, don't forget to change the cylinder from body to component by clicking Create Components from Bodies. Let us view the components all together and drag them away from each other so we can clearly see the holes we will define pin connections from later. Now what we want to do is to let this crank revolve about this hole and also about this hole over here. To do so, click on Assemble, hover down to and click Joint, and then select Capture Position. Click the Motion tab, and as you can see, there are a lot of boundary conditions that you can apply. There's this Rigid tool if you don't want to have a relative motion at all between your objects, the Revolute tool, which is what we're going to use, the Slider tool, and so on. So click on Revolute, go back to Position, and click the Select button located beside the Snap under the Component 1. Afterwards, select this hole in the crank. So as you can see, there was a plus button in it that becomes a circle right after you click it. Now, it will ask you for another point by which the previous selection is going to revolve about. So what we will do is to hover at the pin and select again the center of the hole, which is now marked by this small circle. Now you can see that this first component, which is the crank, will automatically position itself to the second component and preview the motion. Afterwards, hit OK. Before dealing with other components, let us first ground the pin support so we're sure that the entire assembly will be fixed at a certain location and will not be translated anywhere on the screen. Right-click on Pin Support, and then hit Ground over here. Now going back, let us apply a revolute joint between the connecting rod and the crank. Click Assemble, select Joint, select Revolute under the Motion tab, go back to Position, click on Select under Component 1, and then click on this hole on the connecting rod. Orient your view, and then meanwhile click on this hole on the crank. Next, we want our piston to revolve about the other hole on the connecting rod. So once again, click Assemble, select Joint, select Revolute under the Motion tab, go back to the Position tab, click on Select under Component 1. It's basically the thing that we did a while ago, but this time, make sure you have a nice view on your piston, like this. So the next thing that we're gonna do is to carefully select on this hole on the piston, and then reorient your view, and then click on this hole on the connecting rod. Finally, hit OK. For the last joint that we have in this assembly, we want the piston to be sliding with respect to the cylinder. One last time, click Assemble, select Joint, click Motion, and this time select Slider. Go back to the Position tab, and then click the Select under Component 1. Select the center of the topmost surface of the piston, and then reorient your view and select the center of the cylinder's topmost surface as well. Now you can see the motion, but unfortunately it's not yet exactly the one that we wish to have. And in fact, the direction of this motion is flipped the other way around. So to resolve this, click this button over here beside flip. Finally, hit OK. One last step, we want the cylinder to be fixed as well. So right click on the cylinder, and then hit ground. We can actually test the motion of this assembly by clicking on any moving component and dragging it like this. If you want it to move automatically, simply click on the drop-down arrow beside joint, right-click on the first joint that we created, and then select Animate Model. So there you go. You may press Escape on your keyboard in order to stop the animation. That's it. Thank you for watching this video. I hope you learned something, and if you do, don't forget to hit like and subscribe.